Hello everyone. In this video I will do an example which covers how we use the test of increasing decreasing to determine the increasing decreasing intervals for a function. Well, the example goes like this: use the test for increasing decreasing from this point, and you may not see this part to determine the intervals on which the function is here x cubed minus 6x squared plus 9x plus 2 is increasing or decreasing. Well, we will go one by one. Step one is that we want to use the increasing decreasing test. It means that we have to find the signs of f prime. So it will start with finding f prime. F prime is going to be 3x squared minus 12x plus 9. Then step 2, the table of sign, the sign table for the derivative. For that we need to set where the derivative is 0. Well, 3x squared minus 12x plus 9 is equal to 0. We have to solve it. Well, let me just factor out that 3. It will give me 4x plus 3 equals to 0. But from there you see that I have a quadratic. I can try to do this one: x, two numbers which add up to -4 and then multiply, you get 3. This is -1 and -3. -3. Well, from there I can conclude that there are 2 points at which the derivative, not the function itself, the derivative is 0. Well, let's then start drawing the table for this function. It goes from -infinity up to 1. You have to remember, you have to put the roots or the zeros of f prime in an increasing way. 3 and then plus infinity. Well, I need test values, so test values here. For this part, a number between 1 and -infinity. 0 is a good number. The number between 1 and 3, 2 is a good number. And 4 is a good number for an interval through 3 to plus infinity. Then f prime of x, we know that f prime at 1 is 0. That's what we found before. And at 3 is 0. Plug in 0 at f prime. So f prime, let me write it here. F prime at 0 is going to be 3 times 0 squared minus 12 times 0 plus 9. This is a 9, it's a positive number. So this whole interval is going to be positive. How about f prime at the other test value? F prime at 2 is 3 times 4, 12, minus 12 times 2, 24, plus 9. So this is 9 plus 12 is 21, minus this is -3. It is a negative number. The value of the f prime at the test value is -3. So on the whole interval, it's going to be negative. And at f prime at 4, you can do, and you will see it is a positive value. So it will be positive. So that's the table. Now I want to use the table of signs to determine where the function itself, f, is increasing, decreasing. Where this is where what the test says. It says wherever f prime is, positive, then the function itself is going to be increasing. Let me do this with another color. Um, so when f prime is positive, then the function is increasing. When f prime is negative, the function is decreasing. And when the f prime is positive, then the function is increasing. What we have here is now that f is increasing on these two intervals from negative infinity to 1 and from 3 to plus infinity, and f is decreasing on just this middle piece 1 to 3. I again say it, when you work with increasing decreasing, the intervals need to be just open intervals. So this is an example of how the test for increasing decreasing can be used to determine where a function is increasing and where it is decreasing.